Hey guys, welcome to part two. And in part two, we are going to evaluate, and we're going to do that with a calculator and not a calculator. So first we're going to start with not a calculator. Okay, and so this is where your power chart is very useful. So if you don't have that pulled up, you might want to do that. If you have a way of printing that, that'd be best, or taking a picture of it, or writing it out yourself. I mean, those are some different options you can do. Okay, but when we evaluate, we're just trying to find the value, okay, of the logarithm. And it could be in an equation, but more than likely not. Okay, so we're actually trying to find that exponent, right? That's what a logarithm is. Okay, so what it would look like is something like this: log base 2 of 8. So this expression, this logarithm, can be replaced by a number, right? We said logarithms are exponents. And so we're asking ourselves, what is the exponent that replaces this expression? Okay. So you can do this a couple different ways. I, at least in my head, do the following process. So we rewrite it as an exponential. Okay. So like we were doing the last part, we would say 2. But this time we don't have that answer over here, right? We don't know what that power is. That's what we're looking for. So we say 2 to the what power is 8. Okay, so what did we have before? We had the 2, right? That was our base. We had the y, or the of part. But we are looking for that exponent part, right? What is our value? Okay, so again, even though it doesn't have it in this form, it can be useful to do it that way, because all we're trying to do is find that exponent. So 2 to the what power is 8. We can use our chart. So under 2's, go find out how many times it takes you to get to 8. Okay, or I can start multiplying it in my calculator. Now, be careful, the answer is not 4, right? It's not 2 times 4. It's how many 2's. Okay, so 2 times 2 is 4, and 4 times 2 is 8. And so the actual answer is 3. So log base 2 of 8 is 3. That's what we're looking for, is just that 3. Okay, so again, we are looking for that number when we evaluate. Okay, so what about log base 5 of 625? Okay, so we say to ourselves, 5 to the what power, okay, is 625. Okay, so with your chart, with your calculator, and when I say calculator in this part, it's fine to use a calculator to find this, okay? We have to go through a different process in a little bit that we have to have a calculator for. Okay, so 5 to the what power is 625, and hopefully either on your chart or by working it out, you find that the answer is 4. Okay, because 5 times 5 is 25, times 5 is 125, times 5 is 625. Okay, so what about log of a million? So what happens when we don't have a base? Do you remember what it's called? Okay, right, it's that common log. This one you could put it in your calculator, but why? Okay, honestly, so what is our base? Well, it's 10. So we're saying 10 to the what power is a million. Okay. And 10s are easy. All you have to do is count the zeros. Okay, so 10 to the what power is a million? And so the answer is 6. Okay. So why don't you try this one and check with us in just a second. Log base 3 of 729. So go find what power of 3 is 729. So hopefully you went and checked. So we're asking ourselves 3 to the what power is 729. Using your calculator to find the powers of 3 or your chart, your answer should be 6. Okay. So what about log base 9 of 181st? So we're saying 9 to the what power is 1 over 81. Okay. Now, does that cause you a problem? We're used to 81, right? 9 squared is 81. Okay, well, the 81's in the wrong place, if you will, right, compared to the 9. So how do we account for that? Well, that's a location issue. So we know 9 to get to 81 is 2, but to make it 1/81st, that's when we need a negative. Okay, so negatives show up when we have location issues. Or in this case, we went from a big number to a smaller number, right, from 9 to a fraction, and so we do know a negative has to be involved. Okay, so what about log base 1/6 of 216? Okay. So we might not be very comfortable with 1/6, but go look at your sixes. Okay, so we still want to say 1/6 is what power to make 216. Okay, so we don't have 1/6, but we do have sixes, which is just 1/6 with the location issue. Okay, and so say 6 to what power is 216? Okay, well, it's 3, but again, it's not 6 to the 216th, it's 1/6. Okay, and so that's when a negative has to come to play. So again, we have a negative here, but again, I went from a small number and got larger than 1, so that doesn't make sense unless there was a negative as an exponent that did the flipping. Okay, so do you always have to have a negative with fractions? Oops. So let's say we have log base 4/5 of 16/25. Okay, well, so we're saying 4/5 to the what power is 16 over 25. And the top has to go to the same power as the bottom. So 4 to the what power is 16. And 5 to the what power is 25. Well, 4 squared is 16 and 5 squared is 25. So our answer must be 2. Okay. Do we need a negative? No, because 4 got us to 16 and 5 got us to 25. Okay. So just because fractions are involved doesn't mean that you have a negative. It's all about their size relationship. Okay, so how about log base 3/4, okay, of 64/27? So we're saying 3/4 to the what power is 64 over 27. Okay. Well, is there any way to get from 3 to 64 or 4 to 27? No. Okay, so what happens if I flip it? Okay, so instead of looking at 3/4, what if I look at 4/3? So is there any way to get from 4 to 64? Yes, it's a third power. Okay. Is there any way to get from 3 to 27? Yes, it's a third power. Okay, so 3 is the answer, but is there a negative involved? Yes, because we had to flip the 3/4 to 4/3 to make it work out. Okay, so that's when a negative is involved. Another quick way to look at it is here on 3/4, the top is smaller than the bottom. But when we get to this new one, the top is bigger than the bottom. So there is a switch of power, of size. Okay. If you look here, 4/5 is less than 1, right? The top smaller than the bottom. So is the 16/25. There is no switching of size. Okay, 1/6 and 2/16, right? Top is smaller than the bottom, but here the top is bigger than the bottom. So there was a switch in the size. And so that's when a negative is involved. Okay, same thing here. So that's kind of your clue when a negative is involved. Okay, so I'll write that down, but you have to kind of understand what I mean by that to really get it. So a switch in size between top and bottom indicates a negative exponent. Okay, so why don't you try the form I'm about to write down and then pause your video, try them, and then come back, okay, and check. So let me give you 4 to try. So let's take log base 8 of 1 over 5/12, log base 1/2 of 16, about log base 2/5 of 4/25, and log base 3/18 of about 3/8, okay, of 64/9. So try those and then come back and check them with me. So let's look at this first one. Will a negative be involved? I would say yes, right? Because this is 8 over 1, so top's bigger than the bottom, but here's my bottom's bigger than my top. So automatically I know a negative is involved. Okay. So what power of 5/12 is of 8? The answer is 3. 2s, 3s, -2s, -3s, those show up a lot. Okay, just be ready for lots of answers. Will a negative be involved with 1/2 of 16? Log base 1/2 of 16. Yes, because here I have top is smaller than the bottom, but here the top is bigger than the bottom. So there was a switch of power of size. Okay, so let's look at 2 and 16. 2 to the what power is 16? Okay, it's 4. So our answer is -4. And you can check this, right? 1/2 to the -4th in your calculator will give you 16. Okay. About 2/5 to 4/25. Will we need a negative power? No, because top is smaller than the bottom, top is smaller than the bottom. Okay, so how do we get from 2 to 4 and 5 to 25? It's a second power, right, or a square. Okay, and then finally the last one, log base 3 of 18, sorry, 3 of 8 to get to 64 over 9. Okay, there is a size switch. Top is smaller here but bigger here, so that means we need a negative. And 3 squared gets to 9, and 8 squared gets to 64. So -2. Okay. So again, if you have problems with those, you probably need to stop and let me know and see if we can get it cleared up. Okay. So a couple more that show up is something like log base 125 of 25. Okay. So we're saying 125 to the what power is 25. Well, first thing we should think of, it's got to be less than 1, okay, because we're taking something to a power and we're getting smaller. So we're talking about a fraction of a power. Okay? And I don't have 125 for you on your chart, right? Like I only went to 9 or 10. So we're kind of stuck here. But a little trick for you that works is write these as powers of bases of the same base. Okay? So 125 can be written as 5/3, and 25 can be written as 5/2, or 5 squared, I'm sorry. So 125 is 5 to the 3rd, 25 is 5 squared. And if you'll just take this power over this power, okay, that is the answer. And that has to do with a power rule, okay, which we're not ready to talk about, but this 5 squared, the 2 can go out to the front, and we can work on it that way. But this is the little shortcut way to work on it right now. Okay, so is 2/3 power a reasonable answer? Yes, that's less than 1. Okay, and again, we could check that. So 125 to the 2/3 power is 25. Okay, so that's how we check. If we have log base 64 of 4, I don't have powers of 64 for you. We do know that it has to be less than 1. Okay, not negative though, because we still have top bigger than the bottom, top bigger than the bottom. So it does have to be between 0 and 1. Okay. Also, less than 1/2, because 1/2 is a square root and 64 is 8, right? The square root of 8. So I could reason this down that it has to be less than 8. Sorry, less than 1/2, because the square root of 64 is 8. So 64 is 4 to the 3rd, 4 is 4 to the 1st. Okay. So all we have to do is take 1 over 3, and we get 1/3. Okay, so again, that's coming from those numbers right there. So what about log 9 and then of 1/3? Okay. So here we do have a location issue, right? Top was big, now it's the smallest, so we do have a negative. Okay. But we can still look at it this way. 9 is 3 squared. 1/3 is 3 to the negative first. So this is a negative 1/2 power. Okay. And then finally, what about log base 49 of 243? Whoops, 343, sorry. Well, we know that the answer actually has to be bigger than 1 because 49 to the first is 49. And then 49 squared would be a huge number, right? 2,500, a little bit less than that. Okay, but we do know it has to be bigger than 1. So let's see. 49 is 7 squared. 343 is 7 cubed. Okay, so if we do the ratio of those two, we get 3 halves. Okay, and so we do get 1.5 in this case. Okay, so you can get negative answers, positive answers, fractions, right? Okay, so keep that in mind. Okay, what I'm going to have you do is, at this point, you need to try the 25 problems. Okay, now I know that seems like a lot, but for us to get really good at logs, we are going to have to do a lot of them. So what I have planned for you this week is 25 problems a day just on evaluating logs. Okay, so you don't have to turn these in. You just need to practice them and then check them with the answers I have. Okay, so why don't you take a break and go do that and come back for part 3.